Hi there. Today I'm gonna explain a new interesting paper, StyleCLIP, text-driven manipulation of StyleGAN imagery. This paper proposes an image editing method in a text-driven manner. We can easily manipulate an image by using our own text prompt. Yeah, I like this result image. Barack Obama with a mohawk hairstyle. And the third one, actually, I think it's a kind of creepy output. This method is pretty cool in terms of that previous studies did not provide such an easy interface. By using this work, we can simply input a text prompt, then we can get a manipulated image. First of all, I will introduce a background paper, StyleGAN. StyleGAN is one of the most famous architectures that have capability for generating high-quality images. The main idea is similar to the traditional GAN. We randomly sample a latent vector W. We can get a random realistic image by forwarding the latent vector W through the StyleGAN. The main contribution of StyleGAN is the disentanglement of semantic features. In other words, we can control or separate semantic informations of an image. For example, we can combine source A and the course styles from source B. The course styles include head pose, hairstyles, and face shape. In detail, the latent vector of StyleGAN can be split into three types of styles: the coarse styles, middle styles, and fine styles. The upper latent denote coarse styles because the upper latent can affect the large patch of the output image, and the lower latent can be represented as fine styles such as color schemes. Therefore, we can selectively change the semantic information of an image by utilizing the disentanglement of StyleGAN. Previous studies have proposed various image manipulation techniques. The image manipulation using GAN is generally split into two steps. First, the encoding step. We should find a latent vector W and given image X. Therefore, we encode an image X into latent space. Second, the manipulation step. We can update the latent vector using various methods. So for the encoding step, how can we encode an image X into latent space? Here is a simple gradient descent method. We can get the generated image by forwarding the latent vector W, and we calculate the similarity loss between the generated image and the original image. We then get gradient after a backpropagation step and update the latent vector. By doing so, we can get the generated image that is similar to the original image X. The VGG feature extractor is a common choice for a better encoding result. And generally, the optimization process requires hundreds of gradient descent steps. We can also train an encoder network for encoding an image. For training an encoder network, we prepare a large number of latent image pairs that are randomly sampled. By using these latent vector and image pairs, we then train an encoder network on this dataset. Although the encoder network requires hours of training time, we can encode an image by a single forward pass after training. Now we know how to encode an image into the latent space. So let's check how to manipulate the encoded latent vector. The basic method for manipulation is an interpolation. We can get a morphing animation by easily interpolating between two latent vectors in a latent space. The other method utilizes a learned boundary. This method first learns a decision boundary of an attribute such as gender, age, and then finds a direction vector n for image manipulation. After finding a direction vector, we can update a latent vector along this direction. Now I will explain a powerful model, CLIP, that has been recently proposed. CLIP is a large model that jointly trains an image encoder and text encoder using a large dataset. The CLIP can be used for calculating the similarity between an image and text. It is noted that if an image and text features have similar semantic meanings, the cosine similarity between an image and text feature is high. So here, now we take a look at the main idea of StyleCLIP. StyleCLIP is a method that combines StyleGAN and clip together. For text-driven manipulation, this method simply adds a clip loss to the manipulation process. StyleCLIP optimizes the latent vector in a way that the embedding of the generated image is similar to the given text prompt. For example, if we set the text prompt without makeup, this woman image will be updated in the direction of semantic information for without makeup. Then, as the result, we can get this output image. In detail, StyleCLIP proposes 3 methods. The pros and cons of 3 methods are as follows. The first method is the optimization method that utilizes gradient steps. Secondly, the authors propose a latent mapper that is a kind of encoder network. As mentioned before, the mapper network requires training time. However, after training, the mapper manipulates attributes using only one forward pass. And finally, the authors propose a method for finding global direction vectors for updating a latent vector. The first method is latent optimization. This method is a simple method utilizing a gradient descent to update latent vectors. The objective function consists of 3 terms, and the key factor is the first term. While encoding an input image, we can also optimize the encoded image similar semantics to a text prompt at the same time. In this paper, the authors said that this optimization method requires more than 200 iterations for generating a manipulated image. Secondly, the authors propose a mapper network that is a kind of encoder network. The mapper network is split into 3 networks for coarse, middle, and fine styles respectively. As mentioned, even though this method requires about 10 hours per text prompt, this mapper can manipulate image attributes in a single forward pass. Finally, the authors propose a method for finding global directions. The global direction is input agnostic. In other words, a global direction can be applied to any latent vector. For example, this method first finds global directions such as makeup and height of fade, and then we prepare a latent vector S. We can simply update the latent vector according to these global directions.